Okay, if you remember linear systems, we had three ways to solve them. We used the graphing method, we used elimination, and we used substitution. You could use the same methods for nonlinear systems as well. Okay. We're going to start with the algebraic methods. So both of these problems we're going to do in different ways. They're both similar though. You got a quadratic first and then the linear equation second. Okay. The first method we're going to do is substitution. And we're going to do it on this left one. Okay. Substitution, remember, meant you're completely subbing out one of the variables, and in its place you're going to rewrite what that variable equals. Okay. So you want to use substitution when you can use whatever you want. You can use substitution when one of the variables is already isolated. Okay. Well, in a problem like this where they're both y equals, both your variables are isolated, both your y values are by themselves. So if y equals x squared plus 5x minus 10 and y equals 2x plus 10 plus 18, then the x squared plus 5x minus 10 has to also equal 2x plus 18. So it's just pure substitution. So we're going to set these two equations equal to each other. So we're just going to take, if both of these things equal y, then both of those things also have to equal each other. Okay. All right, so we'll set them equal to each other. I got x squared plus 5x minus 10 equals 2x plus 18. Okay. Well, remember, to solve a quadratic, you have to use the zero product property. And to use zero product property, you have to have everything on one side, and the other side has to equal 0. So we're going to move everything from the right side to the left side. So we'll subtract 2x over. We'll subtract 18 over. And there's going to be nothing left on the right side. That goes away, that goes away, so this is going to equal 0. All right, and then do the subtraction. Well, x squared, there's no other x squareds. 5x minus 2x is 3x. And negative 10 minus 18 is negative 28. Okay. So now we have a quadratic that equals 0. Now to use the zero product property, it has to be factored. So we're going to have to factor this. Okay, it's an x squared, 1x squared, so you can just do product sum. What multiplies to 28, negative 28, and adds to 3. Okay. Run through the factors of negative 28, and you'll find out that it's positive 7 and negative 4. Positive 7 times negative 4 is negative 28. Positive 7 plus negative 4 is positive 3. That works. All right, and then use the zero product property. We've done it a bunch. So we know that our x values are going to equal negative 7 and positive 4. However, those aren't our answers. Okay. Remember, we're trying to find the ordered pair and where these graphs intersect. So we know the x values, but we don't know the y values. So we're going to have to plug that back in. Remember, the system of equations always has an ordered pair answer. Okay. Well, if we know negative 7, we know x is negative 7, and we know x is 4, that means we're going to have two solutions. So if you need to figure out y, you got to plug both these values back into the original equations. Okay. Now you could pick either equation. You could pick the quadratic one, or what most people would do is they pick the linear one. Linear one's easier. There's only one x value. Okay. All right, so we'll take that linear equation, y equals 2x plus 18, and wherever we see x, we're going to plug in our x values. In this case, negative 7 over here. Okay. That's negative 14 plus 18, so y equals 4. Which is going to be the ordered pair negative 7, 4. Okay. Do the same thing on the other side with 4. Okay. The y's value is going to equal 2 times 4 plus 18. So y is going to equal 26. Or rather, the ordered pair 4, 26. So that one had two solutions. Remember, a linear versus a quadratic could have two solutions. So those two graphs would intersect at those 2 points. Oops, 26, not 2. Okay, so that was a substitution. Now let's do an elimination one. Okay. Remember, elimination involved adding or subtracting the two equations to eliminate or to get rid of one of the variables. You want to use elimination when you have the same coefficient in front of one of the variables. All right, in this case we do. We have 1y and 1y. Okay. Remember, if they have the same sign you subtract. Opposite sides you add. So we could go ahead and just subtract these two equations. Okay. Elimination is nice in these scenarios because, in substitution we did the substitution and then we had to set it equal to 0. If you have y equals and y equals and you subtract them, it's automatically going to equal 0. Okay. So they're similar steps, but elimination is a little easier, especially when it's set up like this. Okay, now you subtract top equation minus bottom equation. These aren't lined up, so you don't want to do x squared minus 4x. X squared would have to go with any other x squared, and there isn't one on the bottom. So it's just going to be x squared. Okay. Then you're going to subtract the x values. 6x minus 4x is 2x. And subtract the constants. -8 minus 7, careful, is -15. So this one already equals 0. So all we have to do is factor and then solve. So product sum, what multiplies to -15 and adds to +2? It's going to be x plus 5 and x minus 3. Okay. Use the zero product property, and we'll find that x is -5 and x is +3. Now again, we don't care, well, we care about x, but we also need to know what y is. So you want to go ahead and plug these two values back into the linear equation. Again, you could use the quadratic, it's just more, simplifying. The linear is a little easier. All right, so we'll take y equals 4x plus 7, and we'll plug in -5 first. So y equals 4 times -5 plus 7, which is -13. Which is going to be the ordered pair -5, -13. Okay. So that's one place that linear equation crosses that quadratic equation. The other place is going to be wherever 4 times 3 plus 7 is. Okay, and that's 19. So that ordered pair is 3, 19, x, y. Okay, so those are the two algebraic methods, substitution and elimination. They're both very similar. But we could also solve graphically, either using the calculator or doing it by hand. We know how to graph linear equations. We know how to graph quadratic equations. So you can do it graphically. So let's start with the linear equation. Okay. We'll do the linear equation in blue. Okay. Linear equation in slope-intercept form. Remember, it hasn't been that long, but the number in front of the x is the slope. The number at the end with that variable is the y-intercept. So we go ahead and graph this. We have a y-intercept of -3 and a slope of up 6 over 1. Okay, so we're only going to be able to fit 2 on here. And we'll connect the dots. Okay. We also know how to graph quadratic equations. Remember, to graph a quadratic equation, you want to have 5 points. Okay, we'll do this one in red. We know one of the points right away is the y-intercept. The y-intercept is -2. Okay. Now that looks like it crosses there, but it can't. We know it can't because the y-intercept on the linear equation is different. Okay. So it's close, and that's just, the graphing. That's why we don't like graphing it by hand. All right, well, how do we get other points? We can start with the axis of symmetry. We know how to find the axis of symmetry. Axis of symmetry from standard form is the opposite of b over 2a. So b is 4, so the opposite of that's -4, divided by 2 times the a value of 1. So we have an axis of symmetry of -2. Remember, that's also the x value of the vertex. So if we want the y value of the vertex, we're going to have to plug in -2 for x. -2 squared plus 4 times -2 minus 2 is -6. So we know the vertex is the point -2, -6. So we can graph that. -2, -6 is a little off the graph. That's okay. All right, and then remember, we can find another point. Okay. We could also reflect that x value over the y-intercept over. All right, now usually what we would pick is we'd pick something close to the vertex. But I know that that's not going to be it's not going to be right. I know the point's going to be here and it's not going to be the answer. Okay. So let's plug in a different point. Okay. Let's plug in, again, we know that this is here just because the a value is 1. You're going to go over 1, up 1. So let's plug in another point. Let's plug in 1. Okay, because that seems like that's going to be our answer. If we plug in 1 into the quadratic, we're going to get 1 squared plus 4 times 1 minus 2. Which is 3. Okay. So our extra point is going to be the point 1, 3, which happens to be the same point that's on our graph currently. Okay. So if we were to graph this parabola, this one has one solution at the point 1, 3. And then this last one's different than the other ones because this one's a quadratic versus a quadratic. So the other ones were quadratics and linears. This one's quadratic and quadratic. Solve anyway. All right, well, I know I don't want to graph it. Graphing is going to be a pain. So let's solve it algebraically. I'm going to do this one, let's see. I'm going to do this one elimination. Okay. You could also use substitution. All right, well, in elimination, we're going to subtract these. Y minus y is 0. Negative x squared minus x squared, careful, it does not cancel out. It's actually negative 2x squared. And then 9 minus 1 is 8. Okay. So how do I factor that? It already equals 0. How do I factor that? Well, remember, the first step of factoring is always look for a GCF, look for a greatest common factor. This one's not a quadratic. You can't use product sum on it. So it's a quadratic. It's not a trinomial. You can't use product sum. So we're going to look for a GCF. And there is one. It's 2. Okay. But I'm not going to take out 2. I'm going to take out -2. Because I don't want that negative in there with my x squared. So you factor out 2. And you got -2 outside. X squared minus 4 inside. Okay. Well, how do I factor that? Well, if you recall from our patterns, x squared minus 4, it's 2 terms, both are perfect squares, and you're subtracting. This is a difference of squares. Difference of squares always follows the same pattern. It's the square root of the first term and the square root of the second term. One's plus and one's minus. Okay. Don't forget the 2 out front. All right, so now it's factored. Now we solve for x using the zero product property. Okay. Our answers, we've done this a million times, is going to be -2 and +2. Now again, those aren't our answers. It's half of the points, but we still need the y values. So this time we're going to have to plug these back in, and this one we can't really avoid plugging it into a quadratic. We're going to have to because they're both quadratic. So I'm going to do the second one just so I don't have to deal with the negative sign. So I'm going to plug in -2 for x squared plus 1. So my y value is going to be whatever negative 2 squared plus 1 is. That's a y value of 4 plus 1 is 5. And the second one, plug in positive 2 squared plus 1. And you also get a y value of 5. Alright, so you notice these both have the same y value, but that doesn't mean that there's only one solution. Okay? They have the same y value, but they have different x values. We plugged in different numbers. So our two solutions here are going to be negative 2, positive 5. And then positive 2, positive 5. So that one was elimination. Again, you could have used substitution. You also could have graphed that.